Welcome to Module 2, Thinking Outside the Cell with Jordan Goldmeier, Excel MVP. Now, in this module, we're going to talk about thinking differently through problems. Often we're taught in Excel in a very rote manner. We're taught to memorize things. You go through Excel classes that are beginner, intermediate, advanced, and things are sort of pre-designated as being intermediate or advanced. But the way we learn them is very rote. And if we want to build awesome things in Excel, we need to start thinking differently about the problems. And you'll see that as a theme throughout this entire course. We can begin by thinking outside the cell by challenging the common ways in which we do things. And you'll see that when we do that, there's certain types of efficiencies or benefits and advantages that are gained. So let's think about this a little more. What does it mean to think outside the cell? Well, I talk about this in my book, Advanced Excel Essentials. But generally, it's about creativity. It's about thinking differently. It's about pushing Excel's boundaries. And we'll talk about in a second what we mean by that. It's about doing things differently than you've done before, challenging what you know. So having all that in mind, just take a second and have it in mind that we're going to think about problems creatively. I'm going to present a challenge to you. So here's the challenge. We need to write a formula. Here are the rules. When cell A1 is less than 50, you're going to multiply that value. So let's think about this as the reference to A1. We're going to multiply A1 by 1 or by nothing. You know, something multiplied by 1 is itself. When it's greater than or equal to 50, but less than 100, multiplied by 2, greater than or equal to 100, less than 50, multiplied by 3, greater than 150, multiplied by 4. So a fairly easy, a fairly easy problem setup. So what I want you to do is just take a minute and write down how you would answer this. So what was your answer? So most commonly, the way that we answer this is with nested ifs. So if you wrote something that looked like this, that was a nested if, that's probably the most common and conventional answer on how we solve this problem. How many people out there thought about Boolean logic? So let's go through this. Let's talk about how this second one works. Okay, so we're going to start A1 equals 51. Don't worry, I promise this won't get too mathy. Okay, so let's just go take a look at what the formula looks like. So this is our formula that we had on the previous page. We're going to replace A1 into that formula. All right, so far so good. You're following along. You see what's happening. Here's where the weird Excel secret sauce happens. So you see inside those parentheses where it says 51 is greater than or equal to 50, that's our quantity tester. We've seen that from math before. Excel has a funny way of doing things. When it looks at those, it thinks in trues and falses, also known as Boolean logic. So you can see in the first quantity, 51 is greater than or equal to 50. That's going to be true. In the second one, it's not going to be true, so that's going to return a false. And in the third one, it's not going to be true, so that's going to return a false. So here's where something also really funny that happens with Excel. Excel likes to treat trues and falses as ones and zeros, you know, in binary. So this is what is going to happen. It's going to turn those trues and falses into ones and zeros, and it's going to add that value up. And we see that 51 is multiplied by 2, which is correct based off of our problem statement, and equals 102. So that's how Boolean logic works. And actually, it works fairly quickly. And in many ways, it's almost more readable, at least in terms of what the problem statement described. In many ways, it provides benefit. And we'll talk about that later. So let's take a look at this. We have nested ifs and Boolean logic. And just take a moment and think to yourselves, what is the advantage and disadvantage of each? So if we take a look at nested ifs, it's not actually clear what's going on in the problem. By that I mean, if we go back to the problem statement, we'll actually revisit it later, so don't worry if you don't quite remember it. There was a sort of a step of problems that's saying if this didn't equal that, if this didn't equal that. It was kind of linear in our mind. So if I look at this nested ifs, it's just not very semantic is what we would call it. It doesn't actually look like the problem. I've taken that problem and turned it into a sentence. Now, if I look at the second one, that Boolean logic one, it actually does kind of look like the problem, which is very interesting. And I'll talk about why that's important later. And in the second way, the Boolean logic is almost a simplification of the problem. We're looking at it in an almost easier way to think about it, an easier way to write it, and it matches more the problem statement. But I just want to point out, you don't necessarily need to stop there. Part of thinking differently and part of thinking outside the cell is how can I condense it even more if I so choose. So what about this? So in this bottom formula, what I have is that int function. If you've not seen that before, that just means integer. You can also think of it as round down, right? So the problem statement dealt with 50s. And so all I have to do, if I really want to simplify this, is I can take that quantity, so let's say it was 51, and we divide it by 50. 50 goes in there one time, right? So if we're thinking about our old 4th grade division, we don't care about anything else, what the remainder is. It goes in there once, so that's going to return a 1. And then we're going to add 1 to it, so that makes it a 2. And that's going to multiply by the regular, or that's going to multiply by a1, which we've done in the Boolean logic. So I know this bottom one, you're thinking, am I ever going to use that? You may not, but the point here is that there's not really a set way to do things. So when we've done previous work in Excel or previous education, we've been told, put this here, put this chart here. But I want to point out that there's multiple ways to attack a problem, and often the correct answer is a function of what we want to get out of the problem and what we're trying to do. And we'll go back to that because it's very important to think about why we do what we do.